Good afternoon, everyone. For today's video, we are going to discuss about the factors that affect precipitations. First, what is precipitation? Precipitation is defined as the fall of moisture from the atmosphere to the Earth's surface in any physical form. Precipitation is any liquid or frozen water that forms in the atmosphere and falls back to the Earth. As we all know, along with the evaporation and condensation, precipitation is one of the major parts of the global water cycle that has been discussed last meeting. So precipitation have two forms. First, we have liquid, and the example of this is rainfall. Second is the solid, and the example of these are snow, hail, sleet, and freezing rain. Now, let's discuss about the three factors that affecting precipitation. First, we have prevailing winds. Second, we have mountain range. Third, we have seasonal winds. But in this video, we are going to discuss only about the prevailing winds. Prevailing winds are winds that blow consistently in a given direction over a particular region on Earth. Due to factors such as uneven heating from the sun and the Earth's rotation, these winds vary at different latitudes on Earth. Prevailing winds are also important for determining locations of wind farms in order to generate electricity. Prevailing winds also determine the amount of rainfall that different regions get. In southeastern Asia, these winds result in formation of monsoons and deserts. The west coast of South and North America receive abundant rain during the winter due to these winds. Figure 1 shows the prevailing winds and their corresponding cells. First, we have trade winds. Trade winds are, as seen in Figure 1, are created by hot air flowing up and away from the equator, where it gradually cools until it gets to latitudes of about 30 degrees. Next is Hadley cells, named after George Hadley who first described them in 1753. They are responsible for the dry weather patterns at the 30-degree latitudes where the majority of the Earth's deserts lie. Next is Westerlies. When the air reaches approximately 60-degree latitudes north or south, it meets cold air from the poles. Next is Ferrel cells. At this point, the warm air rises and most of it flows back towards the 30-degree latitudes mark. Last one is the polar Hadley cell or polar cell. The final regions are at the poles from 60-degree latitudes to 90-degree latitudes. These winds calls towards the poles and sink to the surface and recirculate. To further understand this figure, let's watch this video.
In this animation, we're going to look at global wind patterns and talk about the reasons why the air circulates the way it does, and also patterns of rising and sinking air and how that relates to precipitation. The engine that drives it all, I guess you could say, is the intense heating by the sun that occurs in the equator areas where the sun is shining at a very high angle of incidence. And this hot air near the equator, being less dense, rises upward. It rises upward and it moves toward the poles, and then it gradually sinks at about 30 degrees north and south latitude. So we create these big spinning circles of air that we call the Hadley cells. Now, near the equator where the air is rising, it loses its ability to hold moisture, and you get a band of high rainfall and low pressure because there's air leaving the equator. Where the air sinks, in these belts at around 30 degrees north and south, you get high pressure sinking air, which creates areas of clear skies and desert climates. Now, as this air circulates and tries to flow back toward the equator along the surface of the Earth, or as some of it heads toward the North Pole or toward the South Pole, the Coriolis effect, the spin of the Earth, causes it to bend and turn, and it's going to create the two big wind belts that prevail on our Earth, 2 out of 3. The the trade winds, northeast trade winds and southeast trade winds, and then the prevailing westerlies. Now these winds curve, and the way they do because of the Coriolis effect. The winds curve to the right of their path, north of the equator. They curve to the left of their path, south of the equator, and they end up flowing from east to west or from west to east. Now the other big factor is what's happening at the poles. At the poles, the air is cold, and the cold air wants to sink. And as that cold polar air sinks, it heads toward the equator, and it bumps into this air heading toward the pole here and toward the south pole here. And it creates an area of rising air, and again, rising air produces high precipitation belts at about 60 degrees north and about 60 degrees south latitude. At the poles themselves, the precipitation is quite modest because the air is sinking, and that creates low precipitation.
That's all about prevailing winds, and the other factors will be discussed by my co-reporters. Thank you.
Good day everyone, I'm Rafa Eminyosa. I'm going to discuss mountain range. This is the one of the factors that affect precipitation. Mountain range. It is a line or a group of mountains that are geologically related or physically close to one another. In these illustrations, explain why the mountain range affect precipitation. The windward side is the side of the mountain that faces in the ocean. So because of the heat of the sun, the water in the ocean goes up, evaporate. Because of the prevailing wind, the water vapor rising up then form into clouds. And kung magkadaghan na sila, mabugatan ng clouds, then the precipitations occurs. So, because of the latitude of the mountain, the precipitations dili na siya moadto sa leeward. Kay dili na siya taman sa windward. So, the leeward side, it becomes dry and it called rain shadow. So, a rain shadow is a patch of land that has become a desert because mountain range block much of the rainfall necessary for plants to grow. So, this is the reason why mountain range is the one of the factor that affect precipitation. So, that's all. Thank you.
Good day everyone, I am Beverly Matugas and I am going to discuss about one of the factors that affect precipitations, which is the seasonal winds. So when we say seasonal winds, it is the winds that blow only during certain season is known as seasonal winds. So when we say seasonal, it is the wind that change their directions with the onset of different season. A change in seasonal winds can affect precipitation. So we all know precipitation, it is the rain. So how does seasonal winds affect precipitations? So prevailing wind also determine the amount or rainfall that different regions get. In Southeastern Asia, so this wind result in the formations of monsoons and deserts. So seasonal winds are similar to land and sea breezes. So when we say land and sea breezes over a vast regions that change directions with the seasons are called monsoons. So monsoons is also a seasonal winds. So it is characterized by a complete reversal in their directions from one season to another. So we traditionally explained as land and sea breezes on a large scale. They blow from the sea to the land in summer and from the land to the sea in winter. So I have here an illustrations for the land and sea breezes. So during day, so land heats up faster and becomes warmer than the sea. Air rises and low pressure is created. So sea is relatively cool. and the pressure over sea is relatively high. So this pressure gradient is from sea to land, sea breeze blows. So, and at night, reversal of condition takes place. So, reversal means kabaliktaran. So, kung sa adlaw, ang land heats up faster, sa gabi ang land lows heat faster than the sea and it is cooler. Land is cooler. And air thins high pressure. So the pressure gradient is from land to sea, it will become the land breeze blows. So the land gradually gets warmer than the oceans in summer of South and Southeast Asia. So the sea breeze blows inland from the oceans and gets very warm and humid. So when we say as the humid air rises over the land, the air cools, producing heavy rains. So when we say humid, so meaning winds that are warm in temperatures and have a lot of moisture, nga mao'y maga-create og heavy rains. So parts of the India receive the most of their rain from the summer monsoons. So next we have the how a monsoons work. So in these illustrations, as you can see in summer, the land is warmer than the oceans. Moist air blows from above oceans to land, and moisture condenses and becomes rain. So, in summer, the land in southern Asia is going to be warmer than the oceans. So, as I discuss gaina, ang humid, it is the wind, that means wind that are warm in temperatures and have a lot of moistures are gonna blow towards land, and these are going to create heavy rains. So the opposite is gonna happen in the summer. So for the land is going to be cooler in the ocean, so we're gonna have cool dry winds blows towards sa land. So it is like two really big differences between the summer and the winter. So I guess if you are going to Southern Asia, so I would not recommend recommend going in the summer because you're gonna hit monsoon season. So in the winter, so land is cooler than oceans. So cool or dry wind blow towards the land. And that's all my report. Thank you.
Good day, everyone. So today we are now on set B, the people and climate. So under people and climate, we have natural climate cycles. Now, cyclical variations in the Earth's climate occur at multiple time scales, from years to decades, centuries, and millennia. Cycles at each scale are caused by physical mechanisms. So when we talk about physical mechanisms, these are physical processes that are broadly affect the living and non-living systems, such as adhesion, surface tension and gravitational effects, convection, and even climate cycles. Climate over any given period is an expression of all the nested mechanisms and cycles operating together. Now, to proceed, there are three types of natural climate cycles. So, namely, we have millennial climate cycle, century scale climate cycle, and interannual climate cycle. Now, let's proceed with millennial climate cycle. So, when we talk about millennial climate cycle, these cycles have occurred at different intensities on multimillennial time scales, from 10,000 to 100,000 year periods. So when we talk about millennial climate cycle, this cycle occurs from 10,000 to 100,000 years. So for the second type, we have century scale climate cycle. Now, when we talk about century scale climate cycle, there are shorter cold warm cycles that occur on approximately 200 to 1,500 year time scale. So century scale climate cycles occur approximately 200 to 1,500 years. Now, what are the possible reasons that these two climate cycles occur? So, one of the possible reasons for climate change on scales of centuries and millennia, like the Little Ice Age, is increased volcanic activity. Now, one of the examples that these millennial and century scale climate cycles occur is through volcanic activity. Great volcanic eruption release huge amounts of gases and aerosol particles which impact global climate by reducing the amount of solar radiation reaching the Earth's surface. And this result to the lower temperature and change the atmospheric circulation patterns. And the result of those are a cold summer and severe winters for the period that follows. Let's proceed with the last type of the natural climate cycles. So we have interannual 3-decadal climate cycles. Now this climate cycle is ocean atmosphere interactions regularly cause climate cycles on the order of years to decades. Now interannual 2-decadal climate cycles occur from a year to decades. So one of the most well-known cycles is the El Niño Southern Oscillation, or what we call ENSO, or we commonly known as El Niño or its opposite effect, La Niña. This is an interaction between ocean temperatures and atmospheric patterns, and it occurs 3 to 7 years and bring different weather conditions to different patterns of the world. That would be all for my report, and Ms. Nasito will continue about the natural climate cycle. Thank you and God bless.
The natural climate cycle. Earth wobbles as the sun, moon, and other planets change their relative position. These cyclical wobbles is called the Milankovitch cycle. These cycles have operated throughout time, yielding the alternative layers of sediment you see in cliffs and road cuts. So there are three kinds of wobbles. So when the variations in the angle and its rotational axis is tilted with respect to its orbital plane, it is called obliquity. And when the Earth undergoes cyclical changes in its orbital plane, it is called eccentricity. And the variations in the direction of rotational axis, it is called precession. First, we are going to discuss the obliquity of the Earth's axis. So the angle Earth's axis of rotation is tilted as it travels around the Sun is known as obliquity. So the obliquity explains why Earth has seasons. So as you can see on the illustration, over the last million years, it has varied between 22.1 and 24.5 degrees with respect to the Earth's orbital plane. So what causes Earth's obliquity to change? So as the Earth orbits the Sun, the Earth is pulled by the gravitational forces of the Sun, Moon, and large planet in the solar system, primarily the Jupiter and Saturn. So over a long period of times, the gravitational pull of other members of our solar system slowly change Earth's spin, tilt, and orbit. So how does the obliquity of the axis of the Earth affect the seasons? So as the axial tilt increases, the seasonal contrast increases so that the winters are colder and summers are warmer in both hemispheres. So today, the Earth's axis is tilted 23.5 degrees from the plane of its orbit around the Sun. Next is the eccentricity of the Earth's orbit. So the Earth's annual pilgrimage around the Sun isn't perfectly circular, but it's pretty close. Over time, the pull of gravity from our solar system's two largest gas giants, planets, which is the Jupiter and Saturn, it causes the shape of the Earth's orbit to vary from nearly circular to slightly elliptical. So the eccentricity measures how much the shape of the Earth's orbit departs from a perfect circle. These variations affect the distance between the Earth and the Sun. So kung ang obliquity explains why the Earth has seasons, in the eccentricity, it explains why our seasons are slightly different lengths. So for example, with summers in the northern hemisphere currently about 4.5 days longer than winter, and spring about 3 days longer than autumn. So as the eccentricity decreases, the length of our seasons gradually evens out. So next is the elliptic orbit and precession. So precession is the change in orientation of the Earth's rotational axis. It alters the orientation of the Earth with respect to perihelion and aphelion. So first, what is perihelion and aphelion? So aphelion is the point of the Earth's orbit that is farthest away from the Sun, and perihelion is the point of the Earth's orbit that is nearest to the Sun. So if a hemisphere is pointed towards the Sun at perihelion, of course, the hemisphere will be pointing away at aphelion, and the difference in season will be more extreme. So at other times, the ellipse is more pronounced, so that the Earth moves closer and further away from the Sun in its orbit. So when the Earth is closer to the Sun, our climate would be warmer.
My topic for today is people's impact on climates. What is the relationship between people and climates? So, population growth, along with increasing consumption, tends to increase emission of climate change greenhouse gases. So rapid pollution growth worsens the impact of climate change by straining resources and exposing more people to climate-related risks, especially in low-resource regions. Human activities contribute to climate change by causing change in Earth atmosphere in the amounts of greenhouse gases, aerosols or small particle and cloudiness. So the largest known contribution comes from the burning of fossil fuels, which release carbon dioxide gas to the atmosphere. Human influence on the climate system is clear. This is evident from the increasing greenhouse gases concentrations in the atmosphere. Positive radiative forcing observes warming and understanding of the climate system. Ang greenhouse effect ay isang pangyayari kung saan nadadagdagan ng init ang mundo dahil ito sa pagkabagal sa paglabas ng init dahil sinisipsip ng greenhouse gases ang radiation at ilalabas kahit saan. Tapos sinisipsip na naman muli na siyang rason kung bakit hindi agad nakakalabas ang init sa mundo. Then, human activities, so particularly the combustions of fossil fuels are alternating the climate system. Then, human-driven change in land use the land cover such as deforestations, urbanizations, and shifts in vegetation patterns also alter the climate, resulting in change to reflectivity of the Earth's surface. Emission from burning forests, urban heat islands effect and change in the natural water cycle. Because the primary cause of recent global climate change in human, the solutions are also within the human domain because we understand the cause of climate change that paves the way for effective solution to be developed and deployed. So, climate change effect. So, meron tayong mga climate change effect. Ito ay hotter temperatures. Hotter temperatures, increased heat release, related illness can make it difficult to work and more around. So ngayon na sa panahon ngayon, madaling araw pa lang ay mainit na ang temperature ng init. So, and more severe storm. More severe storm because flooding and landslide. Ang sa year na to, marami nang nababahaan na mga lugar na nagla-landslide. So, because climate change effect. Increased drought. So, increased drought, water is becoming scarcer or gipit in more region. And then a warm rising ocean. The ocean soaks up most of the heat from global warming. This is melt ice sheets and rises sea level. Mga ganito ang mangyayari pag warming rising ocean. Ito. Next, increased drought. So, water is becoming scarcer in more regions. So, gipit ng tubig. Ito ang mangyayari pag gipit ng tubig. Tubig or water. A warming rising ocean. So, the example of warming rising ocean. Warming rising ocean, the ocean soak up most of the heat from global warming. This melt ice sheets and rises sea levels. And then, loss of species, forest fires, extreme weather, and invasive pests and diseases are among many threats. Then, not enough food. So, global rise in hunger and poor nutrients. So, isa na sa climate change effect ang kakulangan ng pagkain. More health risk. So, increased diseases and death. Marami nang nasasakit na then marami nang namamatay because of climate change effect. And then poverty and displacement. Climate change destroying homes and livelihood. So marami ng mga tao na walang mga tirahan, wala na ring mga matratrabahuan. Wala na silang makukunan ng mga pangangailangan nila. So, because of climate change effect. So, that's all my report. And thank you for watching and God bless.